Hi guys, today is the day. It's a little bit awkward, but that's my first video in English. That's not my native language, so don't be harsh on me. Let's start. Basically, we are going to solve today one Leetcode problem. It's labeled as a hard problem, but actually it's not that hard. Please trust me. So let me read the description for you and provide some comments. So we have a library corridor, which is basically a line of seeds and plants. There are n objects in this corridor labeled as S, which stands for seeds, and P, which stands for plants. Okay. So on top of that, we can put dividers. Divider is basically some kind of a wall between two consecutive elements in our array. So we have to divide our corridor into non-overlapping sections, right? With some additional condition. And the condition is that each section, each block must have exactly 2 seeds, right? We don't care about number of plants, but the number of seeds have to be equal to. Okay. As we understand, there may be different ways how we can divide our corridor. So the task is to find the number of ways to do so, right? And since the number may be pretty big, we have to return it based on modulo 10 to the power of 9 plus 7. It's just a big prime number. And if there is no option to do that, if there is no option to divide the corridor according to our condition, we need to return 0. Okay, let's look into examples. Example number 1. We have 7 objects, right? 4 seeds, 3 plants, and it's grouped like seed, seed, plant, plant, seed, plant, seed. So what we can see is that we basically have 3 options how to divide that, right? So we have 2 seeds on the left, 2 seeds on the right. And from this position, what we need to do is to place a divider somewhere between 1 and 2, 2 and 3, or 3 and 4. Basically, there are 3 options. It's actually a very good example, right? So we see that there are 2 plants together, right, between 2 blocks of seeds. And if you have 2 plants together, there are 3 options to put a divider. Okay, we'll talk about it later, but let's remember that. Okay, the next example is just 2 seeds, right? Okay, if we have 2 seeds, it doesn't matter, right? We have no option to put a divider. If we put a divider somewhere, there will be a section with 0 seeds, which contradicts our description, right? So we have to place just 0, just 0 dividers, right? And there is only one option to do that. So the answer is 1. And the last example, a very productive one as well. So we have just 1 seed, right? Obviously, there is no way to put a divider that divides our group of seeds into sets or sections of 2, right? So the answer is no. The answer is 0. Okay, constraints. So the key constraint we have to talk about is that the number of objects is less or equal to the 10 to the power of 5. Okay, so basically that means for us that we'll have to find a linear solution, right? So the time complexity have to be linear. Otherwise, we won't be able to pass all the test cases if the test cases are challenging. Okay, so that's pretty much it in terms of problem description. Let's do some drawings. Okay, basically what we need to do is to build our intuition first, right? Let's do some intuition first, and then we can find like an optimal algorithm for that. I'm just using circles because I like circles, and let's think about it in this way, right? So color circle is seed, empty circle is plant, right? And we have big number of circles. So we have to solve it in O of n time complexity, right? Basically, that means that most likely we will have to go from left to right and calculate something, right? And basically find an answer in just one pass, right? Maybe we are allowed to do 2-3 passes, but anyway, we cannot go back and do calculations, right? So we need to keep some numbers, some information about previous items using some variables. So that's the key idea. What is a natural way of thinking, right? Let's go from left to right, and once we have 2 seeds, right, we then have to count plants, right? Once we face the 3rd seed, we have to stop, right? We can no longer continue our movement. We have to stop. And basically, that will be our section, right? That will be our section that we'll have to consider. How many ways are there for us to put a divider, right? It feels like the only thing that matters is the number of plants at the end of the section. So we have a section, right? And there is an end part of it. So that's the section, that's the 3rd seed, where the next section starts. So somewhere here are 2 seeds, and here we have some number of plants, right? Well, what is easy to catch here, right? What is really obvious based from example number 1 is that number of options is basically number of plants, count of plants plus 1. So if we have 3 plants here, right, the number of options to put divider is 4. If we have 25 plants in a row, number will be 26, right? So we can pick any position between 2 elements. And if you have like 2 elements, you have 3 positions, 3 elements, you have 4 positions, and so on. So that's a very good part of our intuition-based solution, right? Basically, what we need is to split all our objects into these sections, find out how many plants are at the end of each section, right? And basically multiply all of these, right? Because here we have 4 options. Let's say here we have 3 options, and somewhere at the end we'll have 2. So we'll basically have to multiply all of that, and it will be 24. That will be the answer. Definitely we'll have to use modulo at the end, but the idea is that we're basically splitting our array into these sections. And it's easy to do in just one pass, right? We don't have to do any crazy stuff. We just go from left to right, and we count seeds. Once we have 2 seeds, we start a counter of plants. Once we encounter 3rd seed, right, we stop the counter of plants and multiply. So let's say we have a result that we want to return. We'll start with 1, right? We will count number of plants in a row after we encounter 2 seeds. Once we have 3rd seed, we'll just have this number plus 1, and it will be result multiplied by these plants plus 1, right? And basically that's pretty much it. There are 2 very subtle moments. So the first moment is that we have to return 0. In some situations we will have to return 0. There are 2 situations like that. So the first one is when we have an odd number of seats, right? If we have an odd number of seats, like 3, 5, 7, and so on, we will not be able to divide it using our dividers by groups of 2, right? It's impossible. And there is one even number, and this number is 0, where we also will not be able to do so, right? So in case we have 0 seats or odd number of seats, okay, then we will return 0. In all other cases, we will return the number based on our algorithm. Well, what will happen with the last section, right? So if you have a last section somewhere, and we encounter 2 seats, right? At the end, there will maybe some plants, right? The good part here, so on the first side, there may be some worrying aspect of that, right? Because you may think, okay, we may place some dividers, but what will happen with the answer? But we are good, actually. So the last part, the last section will be calculated automatically. So if we have an even number of seats, we calculated everything before the last section, and the last section will be 1, right? It will not generate additional objects for us because we start counting plants at the end only if we encounter next seat, but next seat will not be present in this situation. So we are good here. Okay, I think it's more or less clear, and we can jump into coding part, right? So I will do my best to code it in kind of understandable way. So the first item I usually do is like mode equals 10 to the power of 9 plus 7. Okay, so I would say first we need to calculate the number of seats, right? C is a counter of, there is a easy trick. So if you don't want to use their variable name, you can always adjust it. Okay, so let's do this. If counter of seats equals 0, or counter of seats mod 2, meaning that it's odd, right? Then return 0. All right, so we successfully passed this part, right? We now guarantee that we have a positive number of seats that is even. Okay, and basically that guarantees that we have at least one way to set our dividers. All right, let's do this. Result equals 1, right? We also need a seat count and plant count. I will do it in the easiest way possible. There are some, let's say, more fancy ways to calculate it, but I'll do just like the easiest way. And for object in objects, right? What we'll do, if object is seat, right? If it's seat, what we need to check. So if seat count is less than 2, we just add it, right? Seat count, else we will reset seat count. Basically, seat count less than 2. What is the opposite? That means seat count is more or equal to, right? So else if seat count is 2, we basically reset it to 1. It's basically this situation. 1, 2, we face the next seat. It will be 1. Result, we multiply result by plant count plus 1, we use modular, and that's pretty much it. If object is plant, right? What we care about, if seed count equals 2, wait a second, we also have to reset plant count. Okay, if the object is plant, if seed count equals 2, that's when we start counting plants, right? Then plant count plus equal 1. Otherwise, we don't care, right? If it's plant, but seed count is less than 2, we don't care. Okay, and I guess we just need to return result. Okay, let's try it. It accepted by test cases, and it passes all the 248 test cases. Okay, so let's quickly talk about time complexity and space complexity. Obviously, both of them are of n, right? We just do one path and we do not store any additional data. So I would say that's kind of obvious. And that's pretty much it. As I promised, it's not that hard. And it's not that hard as a problem, but it was really hard for me to describe it in English. Anyway, if you like this video, please smash like button, subscribe. I will do my best to continue doing that. So hopefully my explanation skills will improve in future. Thanks a lot for watching and see you in the next videos. Have a good day.